Hi and welcome to this video. My name is Lucas, and in this video I'm going to show you 6 of the most important best practices when using Kotlin Coroutines on Android. By following these best practices, you will improve your coroutines-based code quite a lot. This video is based on an article that is called Best Practices for Coroutines in Android from developer.android.com. You can find a link to the article in the description below if you want to get more information. Like in my other videos about coroutines, the examples that I'm going to show you are based on my Kotlin Coroutine use cases on Android GitHub repository. This repository contains many real-world example use cases for using Kotlin Coroutines on Android. I will also add a link to this project in the description if you're interested. The first best practice is about injecting dispatchers into your classes in order to enable testing. On the screen, you can see the view model of an example use case of my coroutines repository. In this use case, we perform an expensive calculation in the background using coroutines. The calculation is performed in the calculate factorial of suspend function. As you can see, we are not hard-coding the dispatcher with dispatchers.default like this, but instead we are using the default dispatcher property. If we scroll up again to the class definition of this example, you can see that this dispatcher is injected via the constructor. Now, what's the benefit of this approach? Well, the benefit is that it enables testing. If we want to test this class, now we can simply inject a test dispatcher instead of a real one in our tests. In tests, it is necessary to use test dispatchers, because this way our tasks are executed immediately instead of asynchronously. By using real dispatchers, our tests would end even before the code in the coroutine gets executed, and therefore we have to use test dispatchers. These test dispatchers execute the code in the coroutine right away. Additionally, test dispatchers give us fine-grained control over the timing of the coroutine execution. Let's now take a look at another example view model. This example use case is really simple, and it only performs a single network request in its perform single network request suspend function. However, you can see in the constructor of the class that I'm only injecting the mock API, but no dispatcher here. So am I violating this best practice here? So the only coroutine that we start in this example is launched in the ViewModels scope. If we go into the declaration of the ViewModels scope, we can see here that the dispatchers.main.immediate dispatcher is hard-coded. As you probably know, the ViewModels scope, coroutine scope, is provided by an AndroidX.lifecycle library. Does this mean that even the Android developers of this library violated a best practice here? The short answer is of course no. In order to replace the main dispatcher in tests, we can simply call dispatchers.setMain and pass a test dispatcher. On the screen, you can now see the main coroutine scope rule. This is a JUnit 4 rule, which is used in the unit tests of the example project. Before each execution of a test function, we call dispatchers.setMain and pass the test dispatcher. If you want to know how this rule can be added to a unit test, please have a look into the unit tests in the example project. So let's sum it up. In order to replace the default or IO dispatcher, we have to make sure that we don't hard-code these dispatchers, but instead we should inject them in the constructor so that we can use test dispatchers in our tests. If we are only using the main dispatcher in our code, we can simply use dispatchers.setMain in our tests. The second best practice says that suspend functions should be safe to call from the main thread. So let's have another look at the calculate factorial of suspend function. Before we do the actual calculation, we use with context in order to switch to the default dispatcher. This way, our suspend function here is indeed main safe. And this means that it is safe to be called from the main thread as it wouldn't block it. This is important because a blocked main thread would lead to a frozen UI. The convention of having main safe suspend functions is very important when using Kotlin Coroutines. If we do follow it, we don't have to think about whether or not we have to change the dispatcher if we want to call a certain suspend function. So the suspend function itself is therefore responsible for switching to the appropriate dispatcher and moving the execution of the main thread, if necessary. If we wouldn't use with context in this suspend function, then our suspend function would not be main safe. This means that we would need to switch to the default dispatcher on the call side whenever we want to call this suspend function. If we forget to do this and we call it directly from the main thread, our app will freeze. To avoid this issue, let's add the with context block again and make the suspend function main safe again. The next best practice says that ViewModels should create coroutines instead of exposing suspend functions in order to perform business logic. So if you need to trigger some business logic from your view, for example, if you want to start a network request when the user presses a certain button, then there are basically two ways to achieve this. The first one is the one that you can see on the screen. Here, the ViewModel is exposing a suspend function, and within the suspend function, a network request is triggered. If the ViewModel exposes suspend functions instead of regular functions, then we have to create a coroutine in the view, so in our fragment or activity. We are doing this here by launching a new coroutine on the lifecycle scope. The second option is to just expose a regular function in the ViewModel and create a new coroutine on the ViewModel scope there. This way, no coroutine needs to be created in the view, and so we can directly call the regular function in the ViewModel. So here are the two options that we have. It is possible to achieve our goals with both approaches, but option number 2 is clearly the best practice. And there are mainly two reasons for this. First, it improves testability, since more logic is located in the ViewModel than in the view. Writing unit tests for ViewModels is much easier than writing instrumentation tests for activities or fragments. Also, unit tests execute much faster than instrumentation tests, since the app doesn't need to be launched on an emulator. The second benefit is that our coroutine will survive configuration changes automatically. This is because the ViewModel scope is not cancelled when the view is destroyed during the configuration change process. If you, on the other hand, launch your coroutine from the view with the lifecycle scope, like we did in the other option, your coroutine will get cancelled on configuration changes and you will have to manually restart it. In general, views should not trigger coroutines that perform business logic, but only coroutines that perform purely UI-related logic, like for example, formatting a string. The next best practice says that the data and business layer, so basically all of our classes that end with either repository, use case, or interactor, should in general only expose suspend functions for one-shot calls or flows if we want to be notified about data changes. On the screen, you can now see an example where the ViewModel calls the getRemote-Android-Versions suspend function in the business layer, and in this function, a network request is performed. Since the business layer exposes a suspend function, it follows this best practice. Now, the big benefit here is that the ViewModel is able to control the execution and lifecycle of the work that happens in the business layer. So for example, if the user navigates away from the screen, the ViewModel is destroyed and the ViewModel scope in which the coroutine that called the suspend function was started is cancelled. This way, the network request that provides data that isn't actually needed anymore is cancelled. On the other hand, if the data or business layer would expose just a regular function and start its own coroutine in some other scope, then we wouldn't be able to cancel this coroutine from the ViewModel, and the network request would continue to run even when the ViewModel gets destroyed. And this wastes a lot of valuable device resources. So in general, you should always expose suspend functions or flows in your business or data layer. However, there are two common situations in which we do want to start new coroutines in the business or data layer. The first situation is whenever we want to achieve concurrent behavior. This could be the case if we, for example, want to perform multiple network requests in parallel. This way, we should still use a suspend function and either use the supervisor scope or coroutine scope scoping function, depending on the required exception and cancellation behavior. By using these scoping functions, newly created coroutines are still linked to the ViewModel scope, so they get cancelled when the user leaves the screen and the ViewModel is cleared. The second situation in which we want to create new coroutines in the data or business layer is whenever we want to trigger work that should not be cancelled when the scope of the coroutine that called the function is cancelled. In this situation, we should use an external scope with a longer lifetime and launch a new coroutine from it. You can see a real-world example of this situation on the screen now. Here, once the network request to load the Android version is initiated, we never want to cancel it again, even if the coroutine that called the suspend function is cancelled. But instead, we want to store the result in the database cache. Here we use a coroutine scope called application scope, which lives as long as the application is alive and never gets cancelled prematurely. Of course, this scope is injected into the constructor in order to facilitate testing. As a final remark, I want to add that if you need to execute tasks that need a guarantee to be run, even if the application itself gets shut down, then you should definitely use Work Manager. Best practice number 5 is to avoid GlobalScope. If you want to perform work that shouldn't be cancelled prematurely, so it shouldn't be bound to a certain life cycle, like for example the life cycle of an activity, fragment, or ViewModel, but instead it should keep on running as long as the application is alive, you may consider using GlobalScope. And this is definitely a viable option. However, a better approach is to create your own scope. For example, the one that you can see on the screen, which is called Application Scope. This one can be injected into the classes in which you want to start coroutines that shouldn't be cancelled prematurely. Injecting our own application scope instead of simply using the global scope has two big advantages. The first advantage is that it enables testing, since we can replace the application scope with a test coroutine scope in our tests. And second, by using our custom application scope instead of the global scope, we can have a common coroutine context for all our coroutines. This means that we are completely free to define the context elements that this scope uses, and we have a central place for this configuration. The only context element that we use for our application scope right now is a supervisor job. Using a supervisor job instead of a regular job is important, because otherwise coroutines that were started in this scope would get cancelled if a single coroutine in this scope fails. Besides the job type, we could also define a custom dispatcher, like for example one that operates on our own custom thread pool. Or we could specify a coroutine exception handler here. If we would instead have usages of the global scope scattered all over the project, then we would need to pass these common context elements in multiple places. With our application scope here, we can define this configuration in a single centralized place. So in summary, using your own custom application scope instead of using the global scope is a best practice and has some benefits. The last best practice is about making our coroutines cancelable. Cancellation in Kotlin Coroutines need to be cooperative. This means that we have to write the code in our coroutines in a way that the coroutines machinery has a chance to abort it. The Kotlin Coroutines machinery can only abort a coroutine if it gets suspended, or if there is a check for cancellation. Let's have a look again at the calculate factorial of suspend function that we have seen earlier. The factorial is calculated in the for loop, and while the for loop is running, the coroutine is never suspended. And there is also no check if the job of the coroutine is still active. This means that even if we cancel the coroutine that caused the suspend function, the calculation will continue to run. And this is a problem, as it would waste a lot of valuable device resources, because the calculation keeps on running, although its result is actually not needed. So how can we fix this? The first solution would be to give the coroutine a chance to suspend. And this is done by calling a suspend function of the Kotlin standard library, like for example delay or with context. Since all the suspend functions of the Kotlin standard library are cooperative regarding cancellation, calling such a suspend function will immediately throw a cancellation exception. So if your coroutine uses suspend functions of the Kotlin standard library regularly, then your coroutine is already cancelable and you don't need to do anything further. In our case here though, we should call ensureActive in every iteration of the for loop. This way, as soon as the job of the coroutine in which the calculation is running is cancelled, ensureActive will throw a cancellation exception, and the coroutine will end without continuing to perform the calculation. To support proper cancellation, it is also possible to check if the job of the coroutine is still active, or instead return from the function. So please always keep cancellation in the back of your head when creating your own suspend functions. If you need more information about how to make your coroutines cancelable, then you can check out my video about common mistakes when using Kotlin Coroutines. In this video, I'm diving a bit deeper into this topic. I will add a link to this video onto the top right corner of this video. And that's it. I hope you enjoyed this video about the most important best practices when using Kotlin Coroutines in Android applications. If you like this video and you want to learn more about coroutines, like how to implement the most important use cases for coroutines on Android, or how structured concurrency and exception handling works, and how to write proper unit tests for coroutine-based code, and much more, then my complete course about coroutines on Android might be interesting to you. And you can find a link to the course with a nice discount directly below the video. And of course, I would love to welcome you on board of this course and to fully master Kotlin Coroutines on Android together with you.